everyone, so today we're going to be doing a little bit of matchmaking using the leftover Christmas chocolates to talk about an important decision maths topic called matchings. Now, before we can get stuck in, the first thing that we need to understand is the concept of a bipartite graph. Now, a bipartite graph is a graph that has two distinct sets of vertices whose edges connect vertices from the two distinct sets. Now, it's also very important to note that no edge can connect two vertices from the same set. So let's try to visualise this. Here we have a set A consisting of milk chocolate buttons and a set B consisting of white chocolate buttons. We can have an edge, here represented by a matchmaker, connecting a milk to a white chocolate button, but not a milk to a milk or a white to a white, like so. So now we are comfortable with what a bipartite graph is, we can begin to talk about matchings. A matching can be defined as one or more edges connecting a vertex in one set to a vertex in another. Now it is important to note that in a matching, each vertex can only be used at most once. If every vertex in the first set is matched to a vertex in the second set, then we call this a complete matching, and an example of this is currently demonstrated with our buttons of matchmakers. We can also define the concept of a maximal matching. A maximal matching is a matching that uses the greatest possible number of edges. So let's consider our milk chocolate set to have 4 vertices and our white chocolate set to have 5 vertices. The maximal matching here would have 4 edges. It is also important to note that a complete matching is always maximal. So the most common type of question that you tend to come across to do with matchings is the idea of improving a given matching. So let's consider the following problem. I've got 4 friends, Jared, Jamie, Charlotte and Harmony, and I've got 4 boxes of matchmakers that I want to distribute between them. Each of these is a different flavour, so I've got an orange, a mint, a salted caramel and a honeycomb. We can display the information from the table as a bipartite graph. This is demonstrated using our buttons and matchmakers. Initially, I give Jared the orange, Jamie the salted caramel and Charlotte the mint. We can demonstrate this information as an initial matching on a bipartite graph. But notice that this matching could be improved, as currently Harmony doesn't have one of the boxes that she likes. So we are going to introduce a method called the alternating path to improve this matching. So to begin this method, we start with the unmatched vertex on the left-hand side. So in this case, the honeycomb vertex. We need to match this vertex to one of our friends by using an edge that is not in the initial matching, but was in the original bipartite graph. So in this case, the only possibility here is to match to Jared. So now we need to get back to the left-hand side along an edge that was in the initial matching and is also connected to Jared's vertex from the original bipartite graph. So in this case, the only possibility here is to go from Jared to orange. Again, we need to connect to the right-hand side along an edge that was not involved in the initial matching, but was one of the possibilities from the original bipartite graph. So here the option is to go from orange to Harmony. So notice that now that Harmony has been matched with a box of chocolates, we have matched the node that was originally unmatched on the right-hand side. So this is called constructing an alternating path. So in our example, our alternating path goes from honeycomb to Jared to orange to Harmony. So from our alternating path, we now have Jared being matched to honeycomb and Harmony being matched to orange. And recall that in our initial matching, we additionally had Charlotte being matched to mint and Jamie being matched to salted caramel. So our solution to the problem is Jared being matched to honeycomb, Jamie matched to salted caramel, Charlotte matched to mint and Harmony matched to orange. This is a complete and maximal matching. If after this process you haven't found a maximal matching, it may be that you need to investigate starting at a different point. This especially may be the case if there is more than one unmatched node on the left-hand side. So hopefully by now you understand what a bipartite graph is, what a matching is, what complete and maximal matchings are, and how to construct an alternating path. If you enjoyed today's video, don't forget to subscribe to our channel. You can also click the link below to download a worksheet. This will help you to test your understanding and help you to improve.